Today let's see how to do the differential amplifier schematic as well as a test bench. So for that, go to File, New, Cell View. Okay, go to your library and type the name as DIFF score TB because the space is not allowed here. So for that reason, okay, you'll get this window, and after that go to create instance, browse, and here select GPDK 180, and we need two PMOS for that one. PMOS, okay, and we need to change some parameters here. So length is 1 micro, width is 15 micro, okay, height. And one thing you need to observe here, in the differential amplifier is the direction of the source is very important. So here the direction is on upward direction, source is on the upper side, so place another one because you need a 2 PMOS transistors. And for rotating this, just click on this and click here, go to flip horizontal, just click here, you will get this view. Okay, now the source is on the upper side, so as per the circuit diagram you will get the transistor. Okay, so after that we need 2 NMOS transistors. So create instance, browse, and go to NMOS here. Okay, for NMOS you need to change some parameter again. So length is equal to 1 micro and total width is 3 micro. Okay, make it as 3 micro. Okay, so hide, and the direction here is it's as it is, but whereas here it need to change. So you need to flip this transistor as per your circuit diagram. So for that, go to, just click here, flip horizontal, and click here, you will get that horizontal flip. Okay, so this again we need to flip horizontal, okay. So do the same for this. So just select this one, flip horizontal. So now we'll get the view as in the circuit diagram. So sources will be not the sources, the source terminal of the transistors, it will be in downward direction here. So after that, now we'll go for another 2 NMOS transistors. So for that, so just I have selected the NMOS and just change the parameters here, make the length as 1 micro and width as 4.5 micro. Click on hide and place it here. So another one also, place it here. It's also of same parameters, that's why. So just change the direction of the source. So just click here and flip horizontal. Click horizontal, we'll get this view. After that, you need to select pin for these circuits. So for that, just click on press P or go to create a pin. Okay, so I'm using press P, that is shortcut. So we need some pins, that is VDD, VSS, V1, V2, okay, and IDC. So all these pins are input, so make the direction as input. So click on hide and place wherever you want. First a VDD, next here are the VSS. So here the V1, V2, okay, and the IDC here. You need a pin, IDC pin here. So for that IDC, so after that once again go to the pin and Vout, OUT, another pin we need. Make the direction as output, okay, just click OK and place here the Vout, okay. So this V1 and V2, just move it to this, move it here, so because the connections to V1 and V2 are here, that's why. This is V1 and V2, that is Vout and IDC, VSS, okay. Got all the pins, I think. So after that, start connecting the circuit using this narrow wire. Just click here and short these things. So if there is any variations in the wire, just move and make it straight, okay. This will no matter anyway, it doesn't matter whether it's straight or some variations will be allowed, it will not show any errors, but for our convenience we'll make it straight and for a neat presentation, okay. So just click here, these two pins are shorted and this is connected to this, okay. These terminals, okay. After that just connect here, okay. There is another connection here, this is V1 to this terminal and V to this terminal. Make it straight. Okay. Let's connect these two pins. ADC here. So these two source terminal are shorted and the VSS is connected here. think almost all connections are completed. So here we need to do one more thing, the extra thing, that is just go to label, create wire label, create wire name and type it as VSS and place it here. It's just a label where we are using, don't do anything like that. So just create VSS and hide, just double click here. Okay, just a wire label. So this will help in doing the layout, otherwise it will give an error in the layout. So that's why I'm placing here. So after that just check and save, so no errors are there. After doing this, as usually we'll go for the symbol create cell view. From cell view click OK. So VSS, rearrange the pins, cut VSS here, it is my bottom pin and VDD is my top pin. So otherwise all these are well arranged. So after that click OK, you'll get this symbol. Just check and save, no errors are there in the symbol. Next go to file, new, differential amplifier, just give underscore TB to it. So ATMEYA is my, okay, it's already there I think, just DFF underscore TB. Okay, it's saying it's already exists, so we'll give, if you get this one, just change underscore MP underscore TB. Okay, now click here. Okay, I will get this window. Go to create instance, browse and go to your library. Libraries, okay, ATMEYA, and just select the symbol from it, place it here and take the sources as shown in the figure. So we need two sources here, actually Vsin and VDC. So go to browse, go to analog library, just type Vsin SI. Okay, here the parameters are AC magnitude is equal to 1, okay, offset voltage is 0, amplitude 5 milli, and frequency is 1K. So just click on hide and place it here. Next we need a VDC, DC voltage 2.5 require, place it here and place this and the DC voltage for VSS. And what we need to change here is just make it as minus 2.5 for VSS terminal. So apply, okay. After that we need one pin, that is a Vout, VOUT. Okay, while selecting the pin, just don't forget to observe the direction. So it is already output, so no need to change. After this we need some ground points, G and D. In the same library we'll get it. Just place it here, 1, 2, 3, 4, and we need another source here, that is IDC. So for that make the DC current as 30 micro. This is the specification of that DC current, just connected to the IDC. So place this source here. So let's start connecting. So this is connected to the V1 terminal. This will go to ground. This will go to IDC. Actually it is not connected. Just delete it. Make it once again. It's not connected. Just click on this yellow point and click on the destination point. Then you will get the proper connections. Okay. I think all the connections has been done. Here one connection is it's connected to here. So after connecting all the terminal, just click on check and save. So it's connected properly. I think all of them are connected. So that's why I'm not getting any errors here. So after that, go to launch and click on ADE-L, AC/DC analysis, transient analysis. Give 5 milli moderate. Okay, apply. For DC analysis, save DC operating point, select component parameter, select component, just select the Vsin and VDC, go to choose, give the range, that is minus for you to for you. Click on apply and go to AC analysis, frequency, that is 150 to 100 mega. Okay, start and stop range. Okay, so click on apply. Okay, go set up outputs. You can go here, output, set up output, both are same. Just click on from schematic, select input and output line, just click on run. So you will get the output. So to change the view, make it as horizontal, you will get AC/DC and transient analysis of the differential amplifier circuit. So this completes your differential amplifier schematic as well as test bench simulation. See how to do the layout of the differential amplifier. So for that, go to open your schematic. Let's check that each one of the transistor, whether it is integrated or detached. If source is connected to the body, then make the body type as integrated, otherwise make it as detached. I'll make it as integrated. Okay, apply. Okay, because the source terminal is connected to the body here, so that's why I'm making it as an integrated one. So body type integrated, apply. Okay, so for this it's detached because now body is not connected to the source, so that's why you make it as detached. Apply. Okay, for this also same, make it as detached, click OK. Okay, after that, for this transistor the source is connected to the body terminal, so that's why for this make it as integrated. Body type is integrated. Okay, go to properties and change the body type as integrated. Okay, so after doing this, once again you check whether it is changed or not. Yes, it's changed. And for this terminal, this you have to check before launching the layout, it's very important. After launching the layout, you can't change these things. Okay, so this is integrated. Okay, okay, all my transistor properties has been changed now according to their properties. Okay, so after that, go to launch, click on Layout-XL, create new. Okay, click OK. Now I will get this window of Layout-XL. After that, go to connectivity, generate all from source, click here OK. OK, you'll get the components. First select all the components, change the view first, and check it whether the properties has been implemented or not. Here we have given as integrated. The components are integrated, that is the terminals, not components. The terminals are integrated, the source and the body terminal, and it is detached. You can clearly see here difference between integrated and detached terminals. Okay, and here also have given the integrated, so properties has been changed according to our parameters. So after that, go to connectivity, nets, show hide and incomplete nets. So it will shows the connection between the pins and between all the components. So after that, just stretch the PR boundary, that is place and route boundary, by pressing yes. So stretch as much as you want, okay, according to the size of your components. So now I need to rotate these things because it will look neat, that's why. So I'll select these two components, right click, rotate right. Okay, because these are somewhat bigger than the other components, so it's not mandatory that you need to change or you need to rotate. You can connect as it is you want, but it's better to change because it may fit and it will look good. Okay, we'll place it in a minimum place, that's why. Okay, after that, so as you know, for changing this movement, just press 3 and change the snap mode to any angle as I did before. So move and place it wherever you want. Okay, so I will move little bit near to this. Just select this component and move little bit closer to this. Yes, it's sufficient. I think it's sufficient. Don't take much closer because you may get the width error while doing the DRC. Okay, just select these two components and click move. Okay, just flip these components for easy connection. So now you can see the movement. So see, these pins are connected to this terminal. So make a flip of it so that it can come on the same plane. So rotate, flip, horizontal, as it is flipped. So here also the same, you need rotate and flip horizontal. Okay, now we'll get all the components. See, now it's on the same plane, it's easy to connect, that's why we are changing, and it's not mandatory to change, and there is no rule that you have to do the layout as I did, so you can implement your own ideas. So this is a prototype. What I am doing is okay, so same, I am moving this to PR boundary. Okay, I will place it here. I'll move a little bit higher so I can comfortably place all the components. this. Okay. So after that, okay, before placing the component, align it straight so it can be easy to connect to or to do the connections. So now you can see here, if it's straight, I can connect it very easily. Okay, so that's the one advantage. I'll make it this component also same. Okay, after that, after proper placement of the components, now we'll go for the pins. Okay, to any one corner as per your comfort, and click on each pin to know which pin it is. Just click on it and press Q or go to properties. It's IDC pin, so as we all know, IDC is connected where it is always it's showing the connections, so it is connected here. So I will place the IDC here. So before moving this component, just know it is which pin it is. So it is a V out pin. So now I have placed all the pins near to that connection. After that, just place the via where you need. Okay, so M1 to poly via. We require M1 poly via for V1 and V2 because these pins are connected to the poly type of material. So that's why. There is a metal, you no need to place the. Okay. Let's start doing the connections. here for shorting this, if metal width is more, if it's difficult to match this width, so for that I have one technique. So just take one M12 poly via and place in between wherever you need the connection. Just place it and draw the metal from that via. So you'll get a small width metal here. It's very easy to connect. So from this to okay. So after doing this, just remove this one, delete, or you can place anywhere you want. So now I will delete it. Okay, you'll get the proper connection. You will not get the width error in the DRC for this. So it should not exceed this width. Okay, that is the rule. So here also the same situation. I am doing the same technique here. So I'll place a wire in between to draw the proper metal. Draw the metal from this. So I will take the metal. Okay, after connecting these things, just remove this wire. Okay. So I think all the connections are done. So let's go for DRC errors. To check the DRC, go to Assura and run DRC. Okay, 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 okay. So no DRC errors. So after that, you have to go for LVS, that is layout versus schematic. Okay, okay. So this completes the layout, and we have already run the LVS. There is no any mismatches here, so 0 mismatches has been displayed. So after that, close this one. We'll go for a DRC, that is not DRC, it's RCX, parasitic extraction of this layout. So for that, run RCX. Okay, now it will, as the AV extracted is created, AV extraction of the layout is created. So for viewing that one, go to file, open, and open the AV extracted view. Okay, click here. Okay, so these small components, small red color boxes are the components. To change the component view, just press shift plus F. Okay, you'll get this view. So this completes the layout of the differential amplifier. So this is Abhinandan. Thank you for watching. Thank you.